1.3 algebraic expressions. Algebraic expressions may have like terms. Like terms are terms with same variable with the same exponent. How do you combine like terms? You combine their coefficients. Their exponents remain the same. For example, if you have 4x to the fourth plus 11x to the fourth, it becomes 15x to the fourth. So when you are adding or subtracting polynomials, you make sure that they are lined up in order of degree and perform the indicated operation. So we see we have 4x squared minus 3 minus a negative 2x squared plus 5x minus 1. So our highest degree of both polynomials is 2. So we have a 4x squared. There's nothing at the exponent 1 spot, so we leave it blank. And then we have minus 3. And then we are subtracting the second polynomial. Negative 2x squared plus 5x minus 1. So I prefer to distribute the negative, the minus sign, and change the signs. So then it becomes adding, and now you just add the coefficients. You get 6x squared minus 5x minus 2. When you are multiplying polynomials, if it's a binomial times a binomial like this one, you can use FOIL. So FOIL stands F for first, a squared times 2a, and we know from the previous lesson that you add the exponents to get to a cubed. O is for outside, so we're going to add to it a squared times 3, which goes to 3a squared. I stands for inside, so we're going to add to it 5a times 2a, and we get 10a squared. And L stands for last. We get 5a times 3, which is 15a. The nice thing about FOIL is if you are going to have like terms, they typically line up in the middle. So we bring down our 2a cubed, we combine our like terms to get 13a squared plus 15a. There's many special products in multiplying polynomials. The first one is when you have a plus b times a minus b. This is called the sum and difference pattern. And if you were to use FOIL to multiply this out, you would get a squared minus ab plus ab minus b squared. The inside terms would end up canceling out, and you get a squared minus b squared. our next one, we have the quantity a plus b squared. That actually means to take a plus b times a plus b. What you do is you square the first term a, and then take plus 2 times a times b plus b squared. If you have the quantity a minus b squared, it's really a minus b times a minus b, and that goes to a squared minus 2ab plus b squared. If you have a plus b cubed, it goes to a plus b times a plus b times a plus b. Well, we already know that a plus b times a plus b, which is up here in green, becomes a squared plus 2ab plus b squared. Now all we have to multiply it by is one more a plus b, and we end up getting a cubed plus 3a squared b plus 3ab squared plus b cubed. Our last special product is a minus b cubed, and that we know longhand is a minus b times a minus b times a minus b. So we know the first two multiplied together from our shortcut earlier is a squared minus 2ab plus b squared. And now we need to multiply this by our remaining a minus b. It's going to be very similar to the previous one. We end up getting a cubed minus 3a squared b plus 3ab squared minus b cubed. The opposite of FOILing is called factoring, and we're going to start by factoring out the GCF, or the greatest common factor. So we have three terms: 8x to the fourth y squared plus 6x to the third y cubed minus 2xy to the fourth. So we look at what is the greatest common factor of the coefficients. We have an 8, 6, and 2. We can take out a 2. Look at the first variable, x to the fourth, x to the third, x. We take out the lowest amount, which is just x. Look at the next variable, y squared, y cubed, y to the fourth. Take out the lowest, which is y squared. Okay, so we're going to factor it out, which is like dividing it out of each term. When we factor it out, it doesn't disappear. It goes outside. This is really reverse distributing. And we write the leftovers. So we got 8 divided by 2, which is 4. X to the fourth over x is x cubed. Y squared over y cancels out. Plus 6 over 2 is 3. X to the third over x is x squared. Y cubed over y squared is y. Minus 2 over 2 is 1. X over x cancels out. Y to the fourth over y squared is y squared. Sometimes we'll have to factor a trinomial. It will be in the form of ax squared plus bx plus c. In one example, we have x squared plus 10x plus 16. I like to start by listing out my a, which is 1, b is 10, C is 16. I use the X method, where we go A times C and B. So 1 times 16 is 16, B is 10. So we're looking for what two numbers add to 16 and times to 10. That would be 8 and 2. We fill them into x plus 8 times x plus 2. And that's your answer. So this one had A as 1. It's pretty simple, but when A is not 1, you have to do an additional step. So we have 3x squared plus 8x plus 4. A is 3, B is 8, C is 4. A times C up top is 12, B is 8. What two numbers multiply to 12 that add to 8? 6 and 2. So we fill it in, we get x plus 6 times x plus 2. But now, this is where we bring down our a. We have to divide by it. At the 6 and the 2. Now, if it's divisible, we divide. 6 divided by 3, we get x plus 2. If it's not divisible, and you cannot reduce it, the 2 does not get divided by 3, they don't reduce, we move it up to the coefficient. Say 3x plus 2. That is factored completely. Sometimes you're going to have to do multiple factoring. So we're looking at 2x to the 4th minus 8x squared. It's only two terms, so we look for a GCF. And on this one, it is 2x squared. So we divide it out. What we have left is x squared minus 4. X squared minus 4 is, they are both perfect squares. So this is a sum and difference pattern. So it becomes x plus 2 times x minus 2. And that 2x squared is still outside multiplying it. So this is factored completely.